In this video, we'll take an in-depth look at creating a new material, and we'll be focusing on a abrasive material today. I'm on my cam tab here, and all the way on the left, we got our select icon. Click on that. Of course, we choose our machine, our nozzle orifice combination, and then you've got your material pull down. So let's go ahead and look at the standard aluminum here. This here, which says standard, this is something that I'll get into. It's probably not what you think it is, so we'll let you know what that does. And then you've got your choice of thicknesses that are currently available for this material. Click on this, you'll go into your material database. And on the left here, we've got our tree of our different materials and the thicknesses. And we currently have our 1/4" aluminum selected. Now, first of all, if you wanted to make a new thickness, since we're in the thickness area of this tree, down here, lower left-hand corner, this plus button, if I click on that, it'll make a new thickness. If I wanted to make, let's say, 1.5 inches, I always like to get as close to the thickness that I'm going to be at as possible. And we'll also talk about why these numbers here are red. If I take the 1.625, click on plus, prompts me for my new thickness, 1.5, click OK, and then that's going to make a copy of that thickness that I had selected. Right now it's at the bottom of this thickness tree. The next time that we come in here, it'll be in order. Now the 1 inch, see all these numbers are black, the 1.625, they're red. And then also on this 1.5, they're red because I had copied it from the 1.625. And these are red to indicate that these numbers have been modified from the default values. And if you're not familiar with it, water jet cutting, you've got generally 5 different speeds or qualities that people will generally cut at, from the extra fine, slow and smooth, to the extra rough where you're barely getting through the material. And then each of these in turn has a high and low speed, with the idea that as you're approaching the corner, since the bottom of the stream is lagging behind the top of the stream, you want to slow down when you come to a corner to allow the stream to catch up and hopefully get around the corner without having a little defect on your corner. So you got high and low for each of those. And if you click on this edit button here, you'll go deeper into the speeds. And because these are red, these have been modified somehow. If you want to set them back to their default values, click on default. Are you sure? Yes. And again, we've got high and low factors. They're 100% of their normal factors. So if you wanted to adjust, say, the high speed on your extra rough, you can either type the number in there or you can type in a percentage and that will change accordingly. Or if I type in a number, then that calculates the percentage, or type in the percentage and it'll calculate the feed rate for the high speed. Similar thing for low speed. And then IGEMS uses 2 different cornering speeds. For an outside corner, it'll slow down to the low speed. That's the corner speed outer. And if you have an inside corner, it slows down to 50% of that, which is the corner speed inner. And then you've got corner distance. This is how far away from a corner that it's going to start to slow down. And then also this, you'll use that same distance to speed up when it's coming out of the corner. And then steps, which is the number of lines of G code that it's going to use to get from the high speed to the low speed, and from the low speed back up to the high speed, presuming that there's actually enough distance to get all the way back up to the high speed before the next corner. I click OK at this point. We come out here. Again, we see this is red, showing that that's been changed. Go back in here. Let's just set that back to our default. Here we've got some numbers showing what the calculated taper angle control values are for the different qualities, high speed and low speed. We'll come back to that in a different video. Arc factor controls your speed on holes, smaller holes being cut slower than larger holes. And if you want to cut a little bit slower on your holes, you can adjust this number. Generally, I just leave that at 1. And this slider down here allows you to globally adjust the speeds on this particular thickness. If I slide it to the right, see we get faster. If we slide it to the left, we get slower. And the reason this can come in handy is sometimes when you get into very thin materials, the the speeds that are calculated may be a bit aggressive and not actually achievable with water jet cutting. For 1/4 inch, we're going to leave that there. We'll click OK. Or sorry, 1.5 we were working with. If I go up to, I've got some 20 thou aluminum here, click on this, you can see the speeds that it's calculated. If you try to cut at these speeds, first of all, there are not a lot of machines that will actually get up to these sorts of speeds. But if you could actually cut at these speeds, you probably wouldn't be particularly successful. So that's the idea with this slider here. If on a particular thickness you want to cut a little bit slower, a little bit faster, and have this affect all the qualities in one time, you can just slide this and your speeds are adjusted accordingly. Import button can be used to import a older material from IGEMS R9 or earlier. Old auto will use the older cut speed calculator to calculate the feed rates. Let's go back to our 1/4 inch that we started with. A couple of things here. These fields are grayed out. This checkbox here tells IGEMS that we want to use the same abrasive flow rate as is defined in our process settings, and also the same pressure, which normally you leave these boxes checked. If you had a pump and or mini hopper that allowed you to change pressure easily, you could, and you had a material that you wanted to cut at a lower pressure, you could uncheck this box and specify the cutting pressure. But for most people, they'll just leave that checked and cut at the full pressure of the pump. Scroll down a bit and you've got values related to taper angle control, which I've talked about in a separate video, so we're not going to look at that today. On the piercings tab, things related to go figure piercings. For most of your metals, you're going to leave this box for the abrasive flow rate for the piercing check, so it's going to use the same abrasive flow rate for piercing and cutting. Later we'll look at a material where we'll do circular low pressure piercing where we're going to use less abrasive, and then you would uncheck that. And then also most of the time for metals, harder materials, you're going to leave the piercings with cutting pressure also selected. Next up we have this checkbox here for dynamic linear piercing speed. IGEMS has done a lot of testing and has found that if your lead-in length is 15% of your material thickness, that should be long enough to get through if you're doing your piercing speed, essentially at the Q5 speed. If this box is checked, if your lead-in is longer than 15% of the material thickness, then it'll go faster on the lead-in, and if it's shorter than that, it's going to go slower. And then the fastest that it will go should be the rough high speed. Let's take a look at this. We'll go ahead and make a part here. And let's change some lead-in length since this is 1/4 inch. We'll make this one be about 15%. And we'll make this one a little bit longer. We'll leave that one there. Let's see, do that. And that should be enough. So this first one that does 1.76 inches per minute on the lead-in, and then ramps up from there. On the next one, it's going to do 6.8 inches per minute. And then on this one, 39. And then this one is going to be the max of 64. So that's with that box checked. If we go back in there just to see the difference, then that's going to do all of these at 22.33 inches per minute, regardless of the length of the lead-in. Now, if you are using my special post processor, I do also have a thing on this special tab where if you want to go even slower, maybe on different thinner materials, you can set what you want for your thickness range for these different areas: thin, middle, thick. And in this case, if we're less than or equal to 1/4 inch, we can say, all right, let's go even a little bit slower, whatever, 50% of the standard rate. This one here, maybe 75%, and then this one, the normal calculated rate. And then this again would be looking at it with that dynamic box unchecked. So this now will be doing those lead-ins at 11.17 inches per minute. So a couple different ways of controlling your lead-in speed. Down here we have fields for controlling piercing time for different piercing types. And if you're doing circular piercing, the diameter of the circular pierce that you're going to make, and then circular piercing speed. Linear piercing diameter, older versions of IGEMS. If your lead-in length was shorter than, say this, you had this linear piercing distance at 0.25. If your lead-in length was shorter than the linear piercing distance, it would make a little wiggle move back and forth until the travel on the lead-in equaled that linear piercing distance. But because of this dynamic linear piercing speed box, this really doesn't do anything anymore, so you can pretty much disregard that one. And then you also have the choice of using this automatic piercing. And IGEMS has done a lot of testing on the different piercing types. If you check this box, there's an algorithm that'll automatically calculate things like the stationary piercing, circular piercing time, etc. So if you don't know where to start, you can try the automatic piercing, and then if you want to change those numbers, you can uncheck this box and manually put in whatever numbers that you want to use. And then the various tab is where you can define what you want to use as your default values when you're doing nesting for the collar width going around a sheet, and then the default value for part distance between the parts when you're doing nesting. These can be set up per material, per thickness. Got some fields down here that can be used for custom stuff, and then a field that can be used for height setters or height sensors. And next thing we can take a look at is this general tab. On here you can specify which technologies you want this material and thickness to be available for. Let's say you were going to cut some 5 thou thick aluminium and you believe that you can do it water only. You can create a new material. And if you check the water box, then when you select a water only machine, that will be available. Let's come out to here and we'll choose water only. You can see in the pull down list that's the only one that's currently available for the thickness. Click on the little edit button and general tab. This will be available for both AWJ and water only. And let's switch back to an abrasive machine. So now let's take a look at making a new material. Let's say we want to make a different grade of aluminum. Go back into our database here. And if you have a material that's similar to what you're going to be creating, a good place to start is on that material. Since this will be a different grade of aluminum, we'll start with the aluminum level, click on aluminum, then down at the bottom, click on plus. Give you a chance to give it a different name. And that will duplicate the thicknesses that was in that first material I had selected. And then you'll probably want to adjust the machinability for this new material. If this new grade of aluminum cuts faster than the original one we started with, let's say, for example, we want our medium speed to be closer to 45 inches per minute, we can adjust the machinability until it gets to around that number. And to do that, you go to the top level. And then on the general tab, you've got your machinability field. If you Click on this question mark. It'll show you some benchmarks for some standard materials. Basic idea is the bigger the number, the faster the material is going to cut, and as the number gets smaller, it'll cut slower. Mild steel being at 87.6. So we don't have a 3000 series aluminum in here, but we're targeting 45 inches a minute for that 1/4 inch. So we'll adjust this. So we could type in, start with something maybe like 250, and then click back and see where we are. A little bit high. Then we can drop it down a bit. Maybe a little bit low. So you can just kind of keep going back and forth like that until you get it where you want it. And that's pretty close there. In here, you can also adjust the density of the material if it's different. And this new formula checkbox here is similar to when we went into here. There was a slider where we could slow down speeds. That is, of course, just for that particular thickness. This uses a little bit different calculation for feed rates, where it's going to go slower on the thinner and the thicker end of the range for the material. So this will apply to the entire thickness range under this material. So for example, if we look at 1/4 inch right now, 45 that we set up, and if we check this box, then the 1/4 inch is now 44.53. More significant is going to be the difference on the thinner and thicker end of things. Let's uncheck that again and look at the 50th hour at 286 versus 119. And on the other end of the spectrum here, 1.16 versus 0.77. So if you find that you're cutting a little bit too fast in the thicker or thinner materials, you can check this box and slow down there. Put this little graph together to try to summarize that. So this would be the traditional formula, the new formula, and then the difference in the speed. These are millimeters and millimeters per minute. And the blue line is the traditional formula, and then the orange line is the new formula. This is in the thicker range from 100 millimeters, or about 4 inches, up to 250 millimeters, about 10 inches. And you got your percentage. So this range here, the speeds are fairly similar. And then as we get here, we go slower, and again, slower here on the thinner end. So that is the new formula checkbox. You can test that out if you want. If this were a material like glass that's susceptible to shattering when you pierce it, if you check this box here and you choose automatic piercing, it'll automatically put circular pierces on the tool paths. If it's a material, laminate material, and you have a drill on your machine and you check the sandwich material box, and you do the automatic piercing, then it'll choose the drilling piercing type. But for aluminum, we don't need either of those. And now we've got our new 3000 series aluminum setup. Let's talk about this standard thing here. Go back into our material database. If we, up at the top here, group qualities, under each material, we have a standard quality. And you can use this to basically set up different costs for the same material. So for example, down here under this aluminum 5052, we have a quality set up as scrap. And what that allows you to do is, for this standard aluminum 5052, we've got this cost here per pound. And then for this scrap, maybe we bought it at a bargain basement price, you can set up a different cost for that. If we want to set up a different quality for a material for different cost, click on the quality level, click on the plus button, and give it whatever name. And that will make copies of all those thicknesses again. And then you can adjust this cost. And let's say we want to do a cost estimate on this part here at a low cost 1/4 inch. I'll come out here, choose the low cost 1/4 inch, go to our process submenu, cost estimate. And there's that cost, and that's 23 cents based on calculating the material based off the parts. And if we go back and switch it to the standard, so it was 23 cents for the material. And now it's 51 cents because we have 45 cents per pound. So that's what that quality thing is, if you've ever wondered about that. And that is where you set up your cost per pound, because that's a frequent question I get, because it's kind of hard to track that down. Normally when you come in here, they've got this set as group thicknesses, and you can't see that cost field. The only way to see that is really group qualities, and then you can get to that cost field. Then briefly how to delete a thickness. Again, normally when you come in here, your material database will be sorted like this. If I wanted to delete this 5 thousandths thick material, you'll see at this point that this minus button is not active. For that to become active, you need to come up here and choose something like we just did, group qualities. And then you can expand it, and then you can choose it and delete it. And then if you also want to delete it from the other quality we created, expand that one and delete it. And let's take a look at setting up piercing for a fragile material. Go back into our material database. Let's take a look at acrylic. Acrylic is a type of material that if you tried to pierce this at high pressure is going to shatter. And we'll expand this and look at one of these thicknesses. Cutting page will be like normal. Key thing is on the piercings tab, you want to uncheck this as cutting box, and then you want to have this number be significantly different from the normal high pressure abrasive flow rate. Generally, we're going to set that to be about half whatever the abrasive flow rate is for the high pressure cutting. Depending on the abrasive hopper that you have, this isn't actually going to control that abrasive flow rate, but it'll either put in a code, M00 code into the program, so the operator can adjust the abrasive flow on the mini hopper, or if you have a mini hopper with a wheel, it'll tell the wheel to spin at a slower rate. But this number here is not going to be reflective of the actual amount that's coming out of the mini hopper, as that's going to depend on how you calibrate your mini hopper. And then the other key thing is to select the pre-piercing radio button and then set this PSI again to be something significantly different from the normal high pressure PSI value. And depending on the pump, this may or may not actually determine the pressure that your pump goes to. Could either just put in a code that tells the pump to go to low pressure, or it will actually tell the pump to go to this specific pressure depending on the pump that you have. And then we'll click OK. Now if we go OK, if we go to our contour command, if I check this automatic lead box here and click on multi, then it's going to put circular pierces on there because we told it that this is a brittle material. In similar fashion, if we had a material that required drilling and we have a drill on our machine, let's say composite material here, go in and edit this. And let's go to the top level again and general tab. And we've got this one selected as sandwich material. And as long as I've indicated in my machine settings that I have a drill on the machine, then if I do that automatic piercing, then it'll select the drilling type for the lead in there. Piercings, you can leave this like regular metals, where we're going to piercing after we do the drilling. We'll come back and pierce with high pressure through those drill holes, so you can keep the abrasive flow rate as cutting box checked and the radio button with cutting pressure selected. And let me check in my machine settings to see if this one has a drill on it. Has drilling tools. Go to our contour command. Got my automatic lead type selected. do my multi, and then that changes that to be a pre-drill. That's a little bit about making and modifying materials. If you have any questions, let me know. Thanks.